Most people think the tech industry was built by entrepreneurs, garage startups, and Silicon Valley visionaries. But the real story begins somewhere very different: the Cold War.
After World War II, the United States and the Soviet Union entered a technological arms race unlike anything in history. Missile detection systems, global military communications, processing enormous volumes of intelligence data. Suddenly, governments needed something that barely existed: computers.
To solve those problems, governments poured billions into universities, research labs, and private companies. That investment didn't just build military systems, it built an entire new industry.
Semiconductors, satellite networks, early computer networking, and eventually the internet itself.
In this episode, we explore how the Cold War built the foundations of the modern tech industry, and how technologies created for global conflict became the infrastructure of everyday life.
So, picking right up on that transition, we really have to look at the immediate aftermath of the Second World War. The whole theater of conflict completely shifted.
Right, it was no longer strictly about taking physical territory with tanks or infantry and traditional supply lines.
Exactly. The new battlefield was entirely informational. And if you look at the sheer scale of the data being generated in the 1950s,
It's staggering. I mean, just picture the visual. Men in these crisp suits operating massive, room-sized tape reel computers.
yeah, you had early warning radar networks scanning the skies constantly, intelligence agencies intercepting uh, global radio traffic,
And a rapidly expanding nuclear arsenal that required absolute, infallible command and control.
which introduces a completely unprecedented logistical nightmare. Because human analysts, no matter how brilliant or how numerous they were, they simply could not process that volume of telemetry and signals intelligence in real time.
They just couldn't keep up.
No, not at all.
Yeah.
You really have to place yourself in the geopolitical tension of that specific era. You have two superpowers with the capability to end civilization just staring each other down.
The stakes are absolute survival.
Exactly. If you are tracking a potential intercontinental ballistic missile launch from across the globe, you don't have hours to run the trajectory calculations on paper.
No, you have minutes.
You have minutes.
And that extreme time deficit that forced the invention of a solution. The pressure to innovate was completely off the charts. We're not talking about a standard business scenario where, a company is just trying to beat a competitor to market.
Right, to secure a slightly better quarterly profit margin.
Yeah, exactly. Survival literally depended on your ability to outcompute the adversary. If your computational infrastructure was slower than theirs, you might not see the incoming attack until the warheads were already detonating.
Which brings up the sheer psychological weight of the engineering involved here. You are building systems where a dropped connection, a malfunctioning vacuum tube, or even a simple mathematical routing error could trigger a false alarm.
And inadvertently start a nuclear exchange.
Exactly. We saw close calls later in the Cold War, like the 1983 Soviet nuclear false alarm incident, where early warning systems erroneously reported incoming missiles.
The entire architecture of early computing was built under the shadow of that exact doomsday scenario. It really makes you pause and think about the environment these engineers were operating in.
It was incredibly intense.
Imagine the pressure of knowing a math error could lead to nuclear war. How would you handle that kind of workplace stress? Let us know in the comments below.
I can't even fathom it, honestly.
Yeah.
But moving past the psychological toll, there's a massive economic reality here that we have to talk about.
Right. The capital required to build these early computational engines was just astronomical.
It was, and that completely shatters the popular mythology of the tech industry. We love the narrative of the rugged entrepreneur in a garage, but the free market simply did not build the computer industry.
Couldn't have.
It couldn't have. In the 1950s, a single mainframe computer cost millions of dollars to develop and deploy.
There was no venture capital ecosystem back then.
No commercial bank, and certainly no small-scale startup that could possibly absorb that kind of financial risk, especially for a technology whose commercial applications were entirely unproven at the time.
So out of sheer necessity, the government, specifically the Defense Department, becomes the ultimate venture capitalist. The state stepped in and essentially seeded the entire technological ecosystem we rely on today.
They poured massive, unprecedented grants into university research labs just to push the theoretical frontiers of what a computer could even do.
And they aggressively funded semiconductor research because they needed reliable components for weapons. The market didn't lead this revolution. The private market followed the massive wake of defense spending.
And if you want to understand how that dynamic actually played out on the ground, You really have to look at IBM.
Oh, IBM is the ultimate example here.
When you examine IBM's operations during the 1950s and 60s, they weren't just a hardware vendor selling boxes to the government. They were practically an extension of the Defense Department itself.
Their computational systems formed the absolute central nervous system of American military infrastructure. I think people really underestimate how deeply embedded they were.
Oh, absolutely.
IBM was providing the raw processing power to run highly classified nuclear blast simulations. They were modeling the complex physics of thermonuclear detonations.
And at the same time, their mainframes were handling military logistics, managing supply chains, and coordinating troop deployments on a staggering global scale.
Not to mention the intelligence processing. The National Security Agency and other intelligence bodies were scooping up vast, endless rivers of classified signals data.
Right, and IBM's architecture was physically sorting, decrypting, and analyzing that information.
And of course, their hardware was the driving force behind the most critical aerospace developments for both the Air Force and NASA. They were building the digital infrastructure of the Cold War block by block.
It really changes the lens through which you view corporate history, doesn't it?
It really does. Does knowing that defense spending, not just free market capitalism, birthed the computer industry, change how you view tech history? Drop a comment and tell us what you think. Because this reliance on military demand leads us directly to perhaps the most important hardware leap in human history.
The integrated circuit.
Exactly. This is a massive aha moment.
It is a crucial technological leap to unpack. Today, we look at the microchips inside our laptops or smart appliances and intuitively assume they were developed iteratively to make consumer electronics smaller, faster, and more convenient.
But convenience had absolutely nothing to do with their invention.
Nothing at all. The integrated circuit was engineered to solve a very specific, very unforgiving military problem.
Ballistic missiles needed onboard guidance computers?
Yes. The physical constraints of aerospace engineering completely forced the industry's hand.
You can't put a gymnasium-sized computer filled with delicate, overheating vacuum tubes inside the nose cone of an intercontinental rocket.
The vibration of the launch alone would shake it to pieces, assuming it didn't melt first.
Right. You had a strict weight-to-thrust ratio. You had to shrink a mainframe's processing power into a durable payload the size of a shoebox.
Exactly. Miniaturization wasn't a consumer luxury. It was a ballistic necessity. And that military necessity drove the rise of companies like Texas Instruments.
Throughout the late 1950s and 60s, they were engineering early integrated circuits and deploying them directly into advanced military radar systems, early space telemetry, and the Minuteman missile guidance systems.
And then you have Fairchild Semiconductor.
Yeah.
They're the ones who pioneered the silicon manufacturing processes that would eventually give Silicon Valley its name.
They figured out how to reliably mass-produce these components. But again, their foundational R&D and their early production lines were kept afloat almost entirely by lucrative, large-scale military contracts.
It's highly accurate to view the defense electronics boom of the Cold War as analogous to the strategic importance of steel during World War II.
That's a great comparison.
Yeah. Military demand took electronics from a niche, highly specialized scientific discipline and forged it into a massive strategic industry fundamental to projecting national power.
The sheer volume and reliable cash flow of those defense contracts allowed these tech companies to scale up their operations, refine their silicon fabrication techniques, and ultimately drive down the long-term unit costs of the technology.
You see this industrial mobilization everywhere you look in that era.
Yeah, Motorola wasn't building consumer cell phones. They were engineering rugged, reliable battlefield communications and airborne radio systems that could survive extreme combat conditions.
Hewlett-Packard was providing highly precise electronic testing equipment and computing hardware necessary for complex aerospace applications.
And Raytheon practically became synonymous with the complex missile guidance algorithms and advanced radar technology that defined modern air defense.
So every time you interact with modern digital infrastructure, you are essentially engaging with repurposed, heavily refined weapons-grade technology.
The lineage of your smartphone traces directly back to a missile silo.
Exactly.
Which is a brilliant point. Look at the device you're using right now. You are essentially holding weapons-grade technology. What kind of device are you listening on? Sound off in the comments.
Because as this silicon technology matured, the theater of competition expanded vertically. It moved from the surface of the Earth up into the atmosphere and eventually into orbit.
The space race.
The space race. Today, it is largely remembered through a lens of human triumph, a purely scientific endeavor for the betterment of mankind.
Right. Planting the flag on the moon.
Exactly. But when you strip away the romanticism and look at the technological imperatives, it's abundantly clear that the space race was a direct, high-stakes extension of Cold War rivalry.
Orbit was the ultimate strategic high ground.
And the race to control it pushed computing technology further and faster than any peacetime commercial program ever could have justified.
Because once you have intercontinental ballistic missiles, your next immediate problem is targeting. You need eyes in the sky.
You need highly complex reconnaissance satellites that can photograph adversary installations and securely beam that telemetry back to Earth.
And to achieve that, you needed miniaturized onboard processors that could navigate spacecraft, manage orbital mechanics, and execute adjustments with a level of mathematical precision that had never been attempted.
To support all of this hardware in orbit, governments had to rapidly construct a massive global infrastructure of ground tracking stations and communication networks.
They were quietly laying the absolute physical groundwork for the modern, globally connected world we live in today.
The networking aspect of this is just...
Okay, before we get to the wild story of how the military accidentally invented the modern internet, make sure you subscribe to our YouTube NC Web Dev channel to not miss all the new stuff coming out.
Because the leap from orbital tracking networks to the internet is where the engineering gets truly fascinating. Let's look at 1969, which gives us the foundation of what we now know as the internet.
It began as a strictly military network called ARPANET.
Funded by the Defense Advanced Research Projects Agency, or DARPA. And it's crucial to understand the core strategic logic behind its architecture. They utilized a brilliant networking concept called packet switching.
Right, and we should clarify how revolutionary packet switching was. Before this, telecommunications relied on circuit switching like an old telephone network.
Right, you had a dedicated physical line open between point A and point B.
The problem is, if a bomb hits a routing hub in the middle of that line, the connection goes completely dead.
Exactly. DARPA wasn't trying to create a global network for civilians to share information or send emails. They were trying to solve a terrifying strategic vulnerability.
They needed to build a communications network that was decentralized and resilient enough to survive a direct nuclear strike.
Packet switching solved this by chopping the digital message into smaller, independent blocks of data packets.
So instead of relying on a single vulnerable cable, these packets could independently find their own way through the surviving network fabric.
If one city or one major communication node was literally vaporized in a nuclear-first strike, the packets would dynamically reroute themselves around the crater,
traveling through entirely different pathways and then seamlessly reassemble themselves at their final destination.
It is the ultimate asynchronous routing protocol. It was designed to guarantee that the military command structure could still communicate and order a retaliatory strike even while the country was actively being destroyed.
It is an incredible historical irony. This ultimate doomsday protocol, designed quite literally for the apocalypse, is exactly what we use today.
Yeah, it is.
The resilient routing architecture created to ensure the military could function after Armageddon is now carrying global e-commerce, streaming our media, and delivering our daily text messages.
It really makes you step back.
Can you believe the internet was designed as a nuclear survival tool? How long could you survive today without it? Leave a comment below.
This naturally leads us to the grand transition. How did we get from doomsday military networks and missile guidance chips to the commercial devices in our pockets?
The transition of these defense technologies into civilian infrastructure was a process that happened gradually and then incredibly suddenly.
By the early 1990s, the Cold War comes to an end. The geopolitical tension thaws. But all of this incredible, globally spanning technological infrastructure, it doesn't just get turned off.
The servers keep humming, the satellites stay in orbit.
The peace dividend, essentially, the technology pivots. Think about the integrated circuits that were meticulously engineered to fit inside the nose cone of a missile.
As defense budgets shrank, those fabrication plants shifted their output. And those same chips transitioned to become the beating computational heart of personal computers, and eventually, every consumer device on Earth.
We see the same pivot in orbit. The satellite networks that were put into space for global military reconnaissance and secure naval communications.
Their bandwidth was pivoted to handle global television broadcasting, commercial telephony, and weather tracking.
And my favorite transition is GPS. The highly complex mathematical systems and satellite constellations designed to provide precise targeting coordinates for nuclear warheads.
That exact technological lineage becomes the global positioning system sitting in your pocket right now, actively helping you navigate afternoon traffic.
And of course, ARPANET, our nuclear-resilient military communication web, slowly opens up to civilian researchers, commercial entities, and ultimately evolves into the global internet economy.
Which perfectly sets the stage for the 1990s Silicon Valley explosion. You had all these massive, highly capable engineering companies, many of which had survived for decades entirely on defense spending, suddenly facing a post-Cold War reality.
They needed new revenue streams, but they had a massive, largely untapped market staring them in the face.
The global consumer. Defense-funded technologies entered mass production for the public at an unprecedented scale.
The personal computer transformed from a niche, highly technical hobbyist tool into an indispensable household product.
The commercial internet began its rapid, exponential expansion into every home and business. And a whole new generation of consumer-focused companies, your Googles, Amazons, and Apples, emerged and built their empires right on top of this pre-existing military-funded infrastructure.
If we look closely at this bridge to the next era, we see a fundamental shift in the very identity of the technology industry. Throughout the Cold War, tech companies were primarily vendors.
They were highly specialized suppliers selling advanced hardware and software to the government.
But as these technologies became civilianized and globally adopted, these companies evolved. They transitioned from being mere suppliers to the state to becoming essential national infrastructure themselves.
And that previews the era of platform power we're stepping into right now. The dynamic has completely inverted.
Today, core defense and intelligence infrastructure is actively running on private, commercial cloud services like AWS, Microsoft Azure, and Google Cloud.
We're seeing privately developed artificial intelligence systems being heavily embedded directly into military targeting, logistics, and surveillance operations.
We have commercial satellite constellations, launched by private aerospace companies, actively providing real-time battlefield communications in modern conflicts.
A handful of massive global platforms now control digital systems utilized by billions of everyday consumers, while simultaneously serving as the backbone for advanced militaries.
More intelligence-relevant data now flows through private commercial servers on any given day than through traditional state-owned intelligence agencies.
Private tech firms today possess raw computing capabilities, capital, and global reach that just a few decades ago belonged exclusively to superpower nations. They are no longer just supporting modern infrastructure, they are completely inseparable from it.
We've seen how the state had to fund private companies to build the technology needed to win the Cold War. But if you look at the sheer scale of the global platforms today, it raises a profound question.
Exactly. If the government essentially created big tech to defend the nation half a century ago, who truly holds the balance of power today, now that private tech companies control more data and infrastructure than the state itself? It's something to think about the next time you use your smartphone's GPS. Let us know your thoughts on this balance of power in the comments below. Don't forget to subscribe, and we'll catch you on the next deep dive.